Hello, happy people. Today is the last day of notes for this week for Algebra 2. Our lesson is on continuously compounding interest. Um, this week we've looked at exponential growth, and then we looked at compound interest and how to solve for time when using logs. So today we're going to look at continuously compounding interest and how to solve with natural logs. So here is our formula if we compound continuously. So that means instead of compounding a certain number of times a year, it continuously compounds second by second. So if that happens, it grows exponentially. So we use that Euler's number E. So here's our equation. I'm going to pause now so you can pause the video and write it down. So for continuously compounded interest, instead of using the a equals p times 1 plus r over n to the nt, we just have a equals p times e to the rt. So a is still our amount of whatever after time. Right now it's going to be money, so amount of money after time. P is going to be our principal amount of money, so the original amount we put in. E, of course, is Euler's number. R is the interest rate as a decimal still, and T is our time in years. So I am going to go through 2 examples with you so that you are ready to use this formula. Our first example, I will pause here for a second for you to write it down. All right. Oh, and remember, you can always pause the video if you need to. A bank offers a CD. A CD is just a savings account with a higher interest rate, and you can't touch that money for a certain amount of time. So a CD that pays 5% interest compounded continuously, we want to know how much would $500 a year yield after 18 years. So remember, our equation we just learned is a equals p times e to the rt. So we know our principal amount is $500. We know that our interest rate is 5%, or if I change that to a decimal by moving the decimal place twice, it's 0.05, and that our t is 18. So if we plug that all in, we're going to get a equals 500 times e to the 0.05 times 18. And if we simplify that, we get 500 times e to the 9th. So if I plug that into my calculator, remember there is an E button on your calculator so that you can easily take e to a power. It's above the natural log button. We will get the number 4051541.96. So as you can see, if we compound continuously, our money grows a lot faster than if we just compound a certain number of times a year. There are no banks that compound continuously. So again, since this is money, our answer is going to be with money. So we're going to have $4,051,541.96. And because we have money, that's why we went to 2 decimal points. All right. So that's just using the equation straight up. All right, besides just using the equation by plugging numbers in, we can solve for time. Since we have E, we can use natural logs. So I'm going to pause here for a second so you can pause the video and write down this example. All right, so it says your parents started a savings account with $100 in it in 1997. If it pays 2% interest compounded continuously, how long would it take to double? So remember, our equation is a equals P e to the RT. We know our P is 100. We know our R is 0.02. And this time we know what our A is. We want to know how long would it take to double. So double 100 is 200. So if we set up that equation, it's 200 equals 100 times e to the 0.02t. So this now looks like an equation that we could have solved by taking the log of both sides. But remember, in order to take the log of both sides, you have to get the power alone. And our power in this instance is e to the 0.02t. So we have to get that alone first. So what we're going to do is we're going to divide both sides by 100. So if I do that, I get 2 equals e to the 0.02t. So now we can take the log of each side, but remember we don't want to use log base 10 because instead of a number this time, we have the number e, and what cancels out the number e nicely is using the natural log of each side. All right, so like I said, we're going to take the natural log of each side. So we're going to have the natural log of 2 equals the natural log of e, the 0.02t. And remember, now that we have a log, we can use our expanding rules to bring that 0.02 down. So we're going to get 0.02t times the natural log of e. Now remember, the natural log of e means e to what power gets me e? And that's 1. And so I have 0.02t times 1, which is just 0.02t. So I'm going to have the natural log of 2. Oops, I forgot my 2 here. There we go. Equals 0.02t. And to get my t alone, I'm going to divide both sides by 0.02. So I'm going to have the natural log of 2 divided by 0.02 equals t. So when I put that into my calculator, I just have to take the natural log of 2, hit enter, and divide it by 0.2. And if I do that, I get 3.34.66. So since we're using t is our time in years, that means it will take 34.66 years to double. I know what you're thinking, that's a long time, and our last continuous example grew really fast. Remember, 2% interest is really low, so it would still take 34 years even if you're compounding continuously to double. So that's to have 100% profit. So no bank is going to just double your money right away. So that is using our continuously compounded interest formula by just plugging numbers in and using the natural log to solve for time. So I hope you are all happy. I hope you're all healthy, and I hope you all have a great day.